Assalamu alaikum, good morning and afternoons to all. Today we are doing experiments that is PN junction. PN junction diode. Firstly, what's our experiment? To draw the characteristic curve of PN junction in a forward bias and to determine its static and dynamic resistance. So this is our apparatus. You can see here this is our voltmeter and this is our milliammeter. This is our battery. This is our output 0.4 volt and this battery will used for a forward bias, and this is 0.100 volt output and this is for reverse bias. PN junction is basically an intrinsic semiconductor. You know what is intrinsic semiconductor? An intrinsic semiconductor cannot conduct electricity, but when we are doping means adding of impurities, but when we adding of impurities then it will conduct electricity. At first time when we adding a pentavalent impurities to an intrinsic semiconductor, then we get a n-type semiconductor. In n-type semiconductor, electrons are majority charge carrier. Just like that, we will adding a trivalent impurities in an intrinsic semiconductor, then we get a p-type semiconductor. In a p-type semiconductor, holes are a majority charge carrier. This is the junction of p-type and a n-type. But when we join this, they will creating a depletion layer. This is the positive terminal of a battery and this is the negative terminal of a battery. And you can see here this V, this is our voltmeter. This is positive terminal and this one is negative terminal. And this positive terminal of a volt will attach to the positive terminal of a battery, and from this one of the points will connect into the positive of diode. And this negative of diode will connect into the positive of a milliammeter. And the negative of a milliammeter will connect it to the negative of a battery. And this is our circuit diagram of a forward bias. We are going to connecting wires in a PN junction. This positive terminal of a voltmeter, we have to connect it with this positive terminal of a battery. This negative of a voltmeter will connect it to the negative of a battery. And this positive of a battery will attach to the forward bias, this diode positive. And this negative will attach to the milliammeter positive, and last wire is connected with this negative of a milliammeter to the negative of a battery. So our circuit is completed. Now we are doing the calculate the values of this. Now I plug here. I can use a pen. Now this is off. Now we will on this. So our PN junction is on. Set here that's 2 volt and here 5 milliampere. Voltmeter, there is a scale. There is a 2 scale in this voltmeter. One is up to 20 and second one is up to 0.4. So for calculating that least count, we have to see there what is division. When we taken here 2 volt, when we taking his 2 volt, now for this time we have to see there that is 0.4. So how we find that division? You can see here that under this 0.4 there is a 10 division. So 10 division is equal to 0.4. So what we find? We find 1 division. Then 1 division is equal to 0.4 divided by 10. Then we get a 0.04. So the 0.04 is a least count in a voltmeter. We have to find a zero error. You can see here there is the needles on 0, so our zero error is 0. And let's move towards the ammeter. You can see here also there is also a 2 scale. One is 0 to 10 and other is 0 to 1. Now we are finding the least count of a milliammeter. You can see here for 5 milliammeter we have to see this dimension up to division 0 to 1. So for that 10 division is equal to 1. We have to find 1 division is equal to 1 divided by 10. Then we will get a 0.1 milliammeter. So this is the least count in milliammeter. So zero error in a milliammeter is also, you can see here, that is 0. Now we are going to do an experiment. Let's we switch on this. You can see here now we will increasing this voltage. With increasing of this voltage, the current will also increase. Now we are increasing this. This is our voltage on 0.04, that is 1 division. On 1 division you can see here there is no deflections in a milliammeter. and you when we increasing again, there is no deviations in a milliammeter. But at a point when we are coming at a 0.2, you can see here there is a little deviations in a milliammeter. Like that, if we increase that voltage and a certain point, you can see that on a 0.4, you can see here that increasing of a meter. Like that, if we increasing that voltage, suddenly the current will increase. You can see here, if we increase voltage again, there suddenly increase and up to and we have to find here also a breakdown voltage. So how we find? You can see here on a certain point, on 0 point something 0.18, there is a current starting to increase. Here there is a increasing of a voltage. On 0.04 there is no increasing of a current. On 0.08 there is also no. You can see here on 5 experiment, on 5 times, there is no increasing of a forward current. There is no increase in a milliammeter. You can see here on 0.2 there is a suddenly increasing of a current. This is our observation column. So next move toward the graph. On the basis of that observation column, we have to draw this graph also. You can see here, this is our forward current and this is our forward voltage. Here on 0.18 the suddenly increasing of a current. The current is increased sharply and exponentially, very fastly the current will increase. This is our experiment. This is PN junction. So our experiment is completed. Thank you. Have a nice day.